This is a demonstration of the prototype of the tool called IDS Combo, developed within the ECO project by the Institute of Information and Communication Technologies of the Bulgarian Academy of Sciences, with Mrs. Petya Ivanova as lead developer. It is well known that machine learning methods are already used and raise significant interest for intrusion detection. Many of them have advantages in classifying certain types of attacks in certain contexts, but disadvantages in others. Our hypothesis is that when we combine several good methods and optimize their outputs, we can enhance the performance both in anomaly detection and classification of certain types of attack. For this presentation, we have used a data set by the Canadian Institute of Cybersecurity from 2017, which has over 80 features in it. This data set is not balanced. It presents benign data and 6 types of attack, but not balanced. Therefore, it is very important to use good pre-processing. Then we have used some well-known and good classification methods. And you can see that some of them, decision tree classification, for example, perform quite well at the level of 99.5%. Random forest methods, extreme gradient boosting, extra tree, k nearest neighbor classification, etc. And they perform pretty well. They exceed 99% accuracy, for example. But when we combine the methods using various ensembling techniques, and the first one is weighted ensembling, we can further enhance that performance to 99.6%, as you can see here, and in the confusion matrix. And when we optimize the combination of the outputs of the selected methods good in themselves, we reach performance at the level of 99.8%. This is when the full feature set is used. When we deal with big data, it is very important to seek ways to reduce dimensionality, and therefore we applied some feature engineering techniques, reducing the features to a quarter of the original number. Performance is fairly well preserved, but still a bit lower in the individual methods. As you can see here, the individual methods. And when we use the assembling techniques with the weighted average, we're again at 99.6%. And when we optimize the combination of outputs, we are practically at 99.7%. That means we can speed up the processes of anomaly detection and classification without losing much of the performance. This is a state of the art in intrusion detection systems applying machine learning methods. And in the next two components, we go beyond the state of the art. The first one is to use when we use the data set to emulate data streams of input data, and that data has six concept drifts that have not been seen in the static training. When we apply these methods for detecting concept drifts and adapting to concept drifts, we can still achieve pretty good accuracy at 99% here. These are all combinations of very advanced machine learning methods. You see here even over 99%. Some of the older methods do not perform that well. Here is, for example, a well-known method of classical method considered already that performs at 91% only, another one at 91.7%, etc. Here is an interesting case. This is a light gradient boosting method that is not being adapted at the moment, and you can see how dramatically its performance drops because it cannot detect properly and adapt to concept drifts. But later you will see what happens when it is adapted to those concept drifts. But again, the point is that when we combine, here is the light gradient boosting method that is trained on all types of attack. It performs very well, 99.5%, which gives us an opportunity to combine static and online training and update the tool at some regular intervals. But the important feature is here. When we used 4 or 5 of the best methods, we achieved the best performance in both detecting and adapting to concept drifts. And the last feature we want to demonstrate to you, this is the explainability, where we again go beyond the state of the art, using some methods, including the so-called shapely values coming from game theory. We can identify the features in the data set that contribute to the classification of all 6 types of attack globally over the whole data set. And it can demonstrate also why a certain instance is classified as a particular type of attack. For example, here is an instance of DOS attack, and the tool itself can show to an expert user why it has been classified as such an attack and the contribution of the most important features for this classification. And when we go to a benign case, it will take a few seconds here to classify and to calculate and provide the explanation. You'll see the opposite pictures, more blue, which shows which features contribute to the classification of this instance as benign, and then the red, here it is, and then the red that show wrongly in this case why it is considered certain types of attack, which can help an expert user to decide and to analyze a particular cyber attack, especially attacks that have not been seen previously. Thank you for your attention.